The first light of dawn touches the summit. Snow glistens like crushed diamonds across the perfect cone. Mount Fuji stands alone against the pale sky, symmetrical, sublime, untouchable. For a moment it appears frozen in time, a postcard, a prayer, a promise etched in stone. But beneath that beauty lies a secret. Beneath the snow and the silence, beneath the pilgrim trails and the cherry blossoms, beneath the weight of 1,000 years of reverence, something stirs. The earth's restless heart beats in the darkness, slow and patient, measuring time not in seasons but in centuries. This is the story of a god who sleeps. And what happens when gods awaken? Mount Fuji is not simply a mountain. It is a symbol woven into the fabric of Japanese identity with threads of spirituality, art, and national pride. Its image adorns everything from ancient woodblock prints to modern currency. Poets have praised it. Pilgrims have climbed it. Millions have gazed upon it with something approaching worship. But Fuji is more than symbol. It is a stratovolcano, one of the most perfectly formed on the planet, and it is very much alive. The last time Fuji erupted was in 1707. More than 3 centuries have passed since ash darkened the skies over Edo, the city now known as Tokyo. 3 centuries of silence. 3 centuries of peace. But silence is not the same as stillness. Japan sits on the edge of chaos. 4 tectonic plates converge beneath the archipelago: the Pacific, the Philippine Sea, the Eurasian, and the North American. They grind against one another with unimaginable force, centimeter by centimeter, year by year, building pressure that must eventually be released. This is the Ring of Fire, the planet's most volatile geological frontier. Here, volcanoes rise like sentinels, their slopes a testament to the violence below. Japan alone is home to more than 100 active volcanoes, each a window into the inferno beneath the crust. And among them all, Fuji stands tallest. At 3,776 meters, it dominates the landscape. Its flanks stretch 40 kilometers across, a vast pyramid of rock and ash built layer upon layer over tens of thousands of years. 3 separate volcanoes have occupied this spot in geological history. The current Fuji, known as Shin Fuji or New Fuji, began forming around 10,000 years ago, burying its predecessors beneath fresh flows of lava and pyroclastic debris. The mountain we see today is an infant in geological terms. Young, volatile, unpredictable. Fuji rises from the border between Yamanashi and Shizuoka prefectures, roughly 100 kilometers southwest of Tokyo. On clear days, the capital's 37 million residents can see the mountain's profile against the horizon, a reminder of nature's dominance in a landscape of concrete and steel. The mountain sits within a complex volcanic system. To the north lies the Fuji Five Lakes region, bodies of water formed by ancient lava flows that dammed rivers and reshaped the terrain. To the east and south, the land slopes gradually toward the Pacific coast. To the west, the Japanese Alps rise in waves of stone, but even they seem to bow before Fuji's majesty. At the summit, temperatures drop well below freezing, even in summer. Snow caps the peak 9 months of the year, creating the iconic image that has inspired artists for centuries. But beneath that frozen crown, heat persists. Fuji's crater yawns 500 meters across and 200 meters deep, a mouth held shut by cold and time. For now, to understand Fuji is to understand the Japanese relationship with nature itself. Shinto, the indigenous spirituality of Japan, sees divinity in the natural world. Mountains, rivers, trees, all possess kami, spirits that must be honored and appeased. And no spirit commands more reverence than that of Fuji. The mountain has been sacred since ancient times. Pilgrims have climbed its slopes for over 1,000 years, seeking purification and enlightenment. At the summit stands a shrine dedicated to Konohana Sakuya, the goddess of Mount Fuji, symbol of delicate earthly life. Her beauty, like the mountains, conceals power beyond measure. But there is another tradition, older and darker. In some legends, Fuji is home to Kagutsuchi, the god of fire whose birth killed his mother and whose rage could consume the world. The mountain is both creator and destroyer, protector and threat. This duality defines Fuji's place in the Japanese imagination. It is revered, yes, but also feared. The written record of Fuji's eruptions stretches back 14 centuries. The first documented eruption occurred in 781 CE during the Heian period. Ancient texts describe fire rising from the mountain and ash falling like snow across the Kanto plain. Over the following centuries, Fuji erupted repeatedly in 800, 864, 937, 999, and 1033. Each eruption left its mark on the landscape and the collective memory. The 864 eruption was particularly devastating. Lava flows poured from Fuji's northwestern flank, engulfing forests and villages. The flows divided Lake Tsunami into what are now Lake Sai and Lake Shoshi, permanently altering the region's geography. Witnesses described rivers of fire that moved with terrible slowness, consuming everything in their path. These medieval eruptions followed a pattern: long periods of dormancy punctuated by sudden, violent awakenings. The mountain would sleep for decades, sometimes centuries, lulling people into complacency. Then, without warning, it would roar back to life. But none of these earlier eruptions would match the fury of what came in 1707. By the early 18th century, Japan had entered an unprecedented era of stability. The Tokugawa Shogunate had unified the country after centuries of civil war. Under the Pax Tokugawa, cities flourished, trade expanded, and culture bloomed. Edo had grown into one of the world's largest cities, with a population exceeding 1 million. Kabuki theater, ukiyo-e woodblock prints, and haiku poetry thrived. It was a golden age of peace. Mount Fuji loomed over this prosperity, a constant presence in daily life. Artists depicted it obsessively. Katsushika Hokusai would later create his famous 36 views of Mount Fuji, capturing the mountain from every angle, in every season, under every sky. But that artistic legacy had not yet been born in 1707. What existed then was complacency. Fuji had not erupted in more than 600 years. Generations had lived and died without witnessing its power. The mountain had become backdrop, scenery, symbol divorced from threat. People built homes on its flanks. Farmers terraced its lower slopes. Pilgrims climbed to the summit in summer, confident in the mountain's benevolence. They had forgotten what Fuji truly was. October 28, 1707, late afternoon. The ground moved. Not the subtle shift of settling earth, but a violent jolt that knocked people from their feet and sent objects tumbling from shelves. In Edo, buildings swayed like grass in wind. Roof tiles crashed into streets. Wooden structures groaned under stress. The earthquake lasted nearly a minute, an eternity of terror. When it finally ceased, survivors emerged into streets filled with dust and confusion. Damage was widespread but not catastrophic. The city had weathered earthquakes before. This was Japan, after all, where the earth moved with disturbing regularity. But this was no ordinary earthquake. The epicenter lay far to the south, off the coast of the Kii Peninsula. What struck Edo that October day was one of the most powerful earthquakes in Japanese history, a magnitude 8.6 monster that ruptured 600 kilometers of the Nankai Trough, where the Philippine sea plate subducts beneath Eurasia. The shaking triggered massive tsunamis that devastated coastal communities. Waves 25 meters high swept away entire villages. Estimates placed the death toll between 5,000 and 20,000. The earthquake became known as Hōei, named for the era in which it occurred. But the earthquake itself was only the beginning. For 49 days, the earth trembled. Not constantly, but repeatedly. Aftershocks rippled through the region, some strong enough to cause additional damage. People prayed at shrines, seeking protection from the gods. Monks chanted sutras. Authorities distributed rice to the displaced. And all the while, something else was happening beneath Mount Fuji. The Hōei earthquake had disturbed the mountain's plumbing system. The sudden release of stress along the Nankai Trough had altered pressure distributions deep underground. Magma that had accumulated in Fuji's chamber for centuries suddenly found pathways opening above it. The mountain began to stir. Small earthquakes rattled communities around Fuji's base. Local tremors, easily distinguished from the larger aftershocks of the Hōei event. These came from above, not below from the mountain itself. Then came the sounds. Villagers reported hearing rumbling from within the mountain, like distant thunder that never ceased. Some described it as the breathing of a great beast. Others heard roaring as though Fuji itself were groaning under some immense internal pressure. Wells began to behave strangely. Some dried up entirely. Others, previously clear, turned cloudy and warm. Springs that had flowed for generations suddenly changed temperature or ceased flowing altogether. Animals sensed the danger. Dogs barked incessantly. Horses refused to approach certain areas. Birds abandoned their nests on the mountain slopes. But people, bound by homes and livelihoods, stayed. December 16, 1707, the day dawned clear and cold. Mount Fuji stood white against the winter sky, its perfect cone unmarred, its beauty unchanged. To the eye, nothing seemed amiss. But beneath the surface, the final countdown had begun. At approximately 10 in the morning, the mountain's southeastern flank exploded. Not the summit, not the crater pilgrims knew from their summer climbs, but a point roughly halfway down the mountainside, at an elevation of 2,300 meters. A fissure ripped open, 300 meters long, oriented northwest to southeast, and from that wound, Fuji began to bleed. To understand what happened on December 16th, we must first understand what Mount Fuji is. A stratovolcano, sometimes called a composite volcano, is built through cycles of eruption. Unlike shield volcanoes, which form from fluid basaltic lava that flows easily and builds gentle slopes, stratovolcanoes erupt more explosive materials. They produce lava, yes, but also ash, pumice, and pyroclastic debris. These materials pile up in alternating layers, creating the steep-sided, conical profile that makes stratovolcanoes so visually striking. Fuji is a textbook example. Its slopes rise at angles of 30 to 35 degrees, each layer representing a distinct eruptive episode. Core samples taken from the mountain reveal its history written in stone-dark basaltic layers interspersed with lighter andesitic bands, punctuated by deposits of ash and scoria. But what drives these eruptions? Deep below Mount Fuji, approximately 20 to 30 kilometers beneath the surface, lies a reservoir of molten rock, a magma chamber. This chamber exists at the boundary between the Earth's crust and the mantle below. Here, temperatures exceed 1,000 degrees Celsius. Rock that would be solid at the surface becomes molten, buoyant, and mobile. This magma is less dense than the surrounding rock, so it rises, seeking pathways toward the surface. But reaching the surface is not simple. The magma must overcome the immense weight of overlying rock. It must find or create fractures through which to ascend. And it must accumulate enough pressure to force its way through. This process takes time, decades, centuries even. Fuji's magma chamber had been filling slowly since the last eruption in 1511, nearly 200 years earlier. Magma seeped upward from the mantle, collecting in the chamber, increasing pressure millimeter by millimeter, year by year. The mountain's edifice acted as a lid, containing that pressure through sheer mass. Until the high earthquake changed everything. The Nankai Trough earthquake of October 28 was a megathrust event, the most powerful type of earthquake on Earth. It occurred where the Philippine Sea Plate, moving northwest at approximately 4 centimeters per year, slides beneath the Eurasian plate. For decades, even centuries, these plates lock together along their interface, accumulating strain. When that strain exceeds the strength of the rock, the plates slip suddenly, releasing energy in a catastrophic rupture. The 1707 earthquake released energy equivalent to thousands of nuclear weapons. The sudden movement altered stress distributions across the entire region. Mountains rose. Valleys dropped, and deep beneath Mount Fuji, fractures opened. These fractures provided exactly what the pressurized magma needed, pathways to the surface. Additionally, the earthquake's seismic waves traveled through Fuji's magma chamber, shaking its contents like a bottle of carbonated liquid. Dissolved gases within the magma began to exsolve, to separate from the liquid and form bubbles. This process is critical to volcanic eruptions. As bubbles form and expand, they increase the magma's volume and further raise internal pressure. Within 49 days, that pressure exceeded the breaking point. The initial explosion was Plinian in nature, the most violent type of volcanic eruption. Named for Pliny the Younger, who documented the 79 CE eruption of Mount Vesuvius, Plinian eruptions are characterized by towering eruption columns, massive ash production, and pyroclastic flows. They occur when gas-rich magma fragments explosively as it reaches the surface. At Fuji, the fissure that opened on the southeastern flank immediately began ejecting material at supersonic speeds. Gas, ash, and pumice blasted upward, propelled by expanding gases within the magma. The eruption column rose rapidly, darkening the sky. Within minutes, it reached the stratosphere. Ash and pumice are both forms of volcanic glass magma that has cooled so rapidly that crystals have no time to form. Pumice forms when gas-rich magma froths and solidifies, creating a rock so light it can float on water. Ash forms when magma fragments into particles smaller than 2 millimeters. Both are products of explosive fragmentation. The eruption column rose to an estimated height of 20 kilometers well into the stratosphere, where atmospheric winds could transport the ash hundreds of kilometers from the source. And the ash began to fall. Volcanic ash is not like wood ash. It is not soft or fluffy. It is composed of angular particles of volcanic glass and rock fragments, sharp enough to damage lungs, abrasive enough to strip paint from surfaces, heavy enough to collapse roofs. And it fell in quantities difficult to imagine. The prevailing winds at stratospheric altitudes blew from west to east, carrying Fuji's ash directly toward Edo, 100 kilometers to the northeast. Within hours, the sky above the capital began to darken. At first, it appeared as a strange haze, dulling the afternoon sunlight. Then the ash began to fall fine at first, like gray snow, then thicker, until it fell in drifts. People rushed indoors, covering their faces with cloth. Animals panicked. Visibility dropped to mere meters. By nightfall, Edo was in darkness. The ash fall continued for 16 days. 16 days during which the sun barely penetrated the gloom. 16 days during which ash accumulated in streets, on rooftops, and fields. The city transformed into a gray wasteland, every surface coated with a thick layer of volcanic debris. The accumulation was measured. In Edo, ash depths reached 15 centimeters in some areas. Closer to Fuji, in the towns and villages of the Kanto Plain, deposits exceeded 30 centimeters. Nearest the mountain, ash buried entire landscapes under meters of debris. 15 centimeters of ash might not sound catastrophic, but volcanic ash is deceptively heavy. Dry ash weighs approximately 1,000 kilograms per cubic meter. Wet ash and rain or snow inevitably falls can weigh 3 times as much. A 15-centimeter layer of wet ash on a 10-square-meter roof section weighs nearly half a ton. Traditional Japanese roofs were not designed for such loads. Made of wood and tiles, optimized for rain and snow, they began to fail under the unaccustomed weight. Throughout Edo and surrounding communities, roofs collapsed. Homes that had stood for generations crumbled under the relentless accumulation. Farmers faced catastrophe. Winter crops, planted in autumn, were buried under ash. Even shallow deposits were enough to kill plants, blocking sunlight and disrupting photosynthesis. Fields that should have been green with young barley lay gray and lifeless. Ash infiltrated everything. It contaminated water supplies, making wells and streams undrinkable. It choked air passages, causing respiratory distress in people and animals alike. Horses died in their stables, unable to breathe. Elderly and infirm humans succumbed to lung complications. The ash turned daily life into a struggle for survival. While ash darkened distant skies, the mountain itself underwent transformation. From the eruption fissure, lava began to flow. This was not the fluid basaltic lava that creates shield volcanoes. Fuji's lava was andesitic, more viscous, more gas-rich, more likely to fragment explosively. But once the initial gas pressure was released, the remaining magma could flow. The lava descended the southeastern slope in tongues of molten rock, glowing orange and red against the ash-darkened landscape. Its advance was measured tens of meters per hour, slow enough that people could flee, fast enough to consume forests, villages, and shrines. The flows reached lengths of several kilometers before cooling and solidifying. Behind them they left black scars on the mountain's flank, new rock, new land, new layers in Fuji's ongoing construction. Simultaneously, scoria eruptions continued from the fissure. Scoria is a type of volcanic rock similar to pumice but denser, formed from less gas-rich magma. These fragments fell near the eruption site, building a cone around the fissure. That cone still exists. Today it is known as Hōei, the Hōei Mountain, a prominent bulge on Fuji's southeastern flank. It stands as a permanent scar, a reminder of 1707, visible from Edo, from Tokyo to this day. Witnesses reported phenomena that seemed supernatural lightning that crackled within the eruption column itself, illuminating the ash clouds from within with flashes of brilliant white and blue. Volcanic lightning is real, though its mechanisms remained mysterious until recent decades. During explosive eruptions, ash particles collide with tremendous frequency within the eruption column. These collisions cause electrons to transfer between particles, creating charge separation. Positive charges accumulate in some regions, negative in others. When the electrical potential difference becomes large enough, the air breaks down and lightning arcs between charged regions. The effect is spectacular jagged bolts of electricity dancing through darkness, thunder mixing with the mountain's roar, a display that combines the fury of thunderstorms with volcanic violence. To those watching from Edo, from the surrounding villages, from ships at sea, it must have seemed as though the gods themselves were at war. The sound, and there was sound. The eruption was audible across the entire Kanto plain. Not merely loud, but profoundly, viscerally physical, a sound felt in the chest as much as heard with the ears. Volcanic eruptions produce infrasound frequencies below the range of human hearing, typically below 20 Hz. These low-frequency waves travel vast distances, barely attenuating with distance the way higher frequencies do. They cause unease, nausea, disorientation. They vibrate buildings and human bodies. But Fuji also produced audible sound, the roar of escaping gases, the thunder of collapsing eruption columns, the explosive fragmentation of magma meeting groundwater. These sounds merged into a continuous rumble punctuated by sharper reports, like artillery fire from the earth itself. People reported being unable to sleep, unable to think clearly. The sound was omnipresent, inescapable, driving some to the edge of madness. And it continued day after day for 16 days. Remarkably, the death toll from the eruption itself was relatively low, likely fewer than 100 people died in the immediate vicinity of the mountain. The eruption, location on Fuji's uninhabited upper slopes, meant that lava flows and pyroclastic density currents did not directly impact major population centers. But indirect effects were devastating. Crop failures due to ashfall led to famine in the following year. Tens of thousands died from starvation and related diseases. The collapse of homes killed hundreds during the ashfall. Respiratory diseases claimed thousands more. The economic impact was staggering. Edo, the shogunate's capital, effectively ceased functioning for weeks. Trade halted, markets closed. The government struggled to distribute relief supplies through ash-choked streets. Agricultural lands across the Kanto plain were rendered barren. It would take years for farmers to clear ash from fields, years more for soil productivity to recover. Some lands were never reclaimed. The eruption marked a turning point in Edo period history. The combination of earthquake and eruption strained the shogunate's finances and tested its authority. Some historians argue that the Hōei disasters began a slow decline that would eventually lead to the Meiji Restoration 160 years later. December 31, 1707, after 16 days, the eruption ceased. The ash clouds dissipated. The rumbling faded. The lava flows cooled and solidified. Mount Fuji returned to silence. But it was a different mountain now. The Hōei eruption had added a new crater, a new cone, new lava flows. The symmetry that artists prized was marred by the bulge of Hōei-san. The mountain's profile had changed. And Fuji has not erupted since. The Hōei eruption occurred on a volcanic island nation, but its effects were largely local. Unlike Krakatoa in 1883 or Tambora in 1815, Fuji's 1707 eruption did not inject enough sulfur dioxide into the stratosphere to cause significant global climate effects. This was partly due to the eruption's duration and style. Plinian eruptions are dramatic, but to alter global climate, an eruption must inject massive quantities of sulfur compounds into the stratosphere, where they form aerosol particles that reflect sunlight. The Hōei eruption was relatively sulfur-poor, and its column, while tall, did not persist long enough to pump sufficient material into the upper atmosphere. Thus, the world beyond Japan remained largely unaware of Fuji's awakening. Europe was preoccupied with wars and dynastic struggles. China and Korea recorded unusual atmospheric phenomena but did not connect them to events in Japan. The eruption was a local catastrophe, not a global one. But locally, the effects would persist for decades. Clearing ash from Edo took months. Laborers shoveled it from streets, dumped it in rivers, piled it in vacant lots. The effort was Herculean, involving thousands of workers and straining the city's resources. Agricultural recovery took far longer. Farmers attempted to plow ash into soil, hoping it would break down and add minerals. In some cases, this worked volcanic ash is rich in nutrients that, over time, can enhance soil fertility. But the sheer volume of ash initially smothered crops and disrupted ecosystems. Famine gripped the region in 1708 and 1709. Rice prices soared. The shogunate opened granaries and distributed emergency supplies, but shortages persisted. Mortality rates spiked, particularly among the poor and vulnerable. Economic recovery was similarly slow. Merchants who had lost inventory struggled to rebuild. Artisans whose workshops had collapsed faced ruin. The disruption to trade networks had ripple effects across the Japanese economy. Yet, gradually, life resumed. Roofs were rebuilt. Fields were replanted. Markets reopened. The resilience of human communities asserted itself. But the memory of those 16 days remained. The eruption entered Japanese cultural consciousness immediately. Woodblock prints depicting the eruption began circulating within months, showing the ash-darkened sky, the glowing fissure, the suffering of Ito's residents. Poets wrote about the event in haiku and longer forms, capturing both its terror and its sublime beauty. The eruption became a theme in kabuki theater, where dramatizations portrayed the suffering and eventual recovery. Most famously, the eruption influenced later depictions of Mount Fuji. Hokusai's 36 views, created more than a century after the Hōei eruption, show a mountain both beautiful and ominous. The bulge of Hōei appears in some prints, a subtle reminder of the mountain's power. The eruption reinforced Fuji's dual nature in Japanese spirituality, sacred yet dangerous, worthy of reverence yet demanding respect. The Hōei eruption left a detailed stratigraphic record. Today, volcanologists can identify the Hōei tephra layer across the Kanto region. It appears as a distinct gray band in soil profiles, a marker horizon used to date archaeological sites and geological features. Studies of the Hōei deposits have provided crucial insights into Fuji's eruptive behavior. Analysis of ash and pumice composition reveals the magma's chemistry andesitic to basaltic andesite, typical of subduction zone stratovolcanoes. The grain-size distribution of the ash indicates explosive fragmentation, with particles ranging from fine dust to lapilli several centimeters across. The formation of Hōei itself is scientifically significant. Flank eruptions like the one in 1707 are relatively rare at Fuji. Most of the mountain's historical eruptions occurred from the summit crater. The 1707 fissure eruption indicates that magma can bypass the main conduit and erupt through the mountain's flanks, a behavior that significantly complicates hazard assessment. Modern monitoring of Mount Fuji builds directly on lessons from the Hōei eruption. Understanding that earthquake-triggered eruptions are possible, scientists closely monitor seismic activity near the mountain. Understanding that ashfall poses a severe threat to Tokyo, civil defense plans emphasize ash removal and respiratory protection. Mount Fuji has been silent for 318 years. This is the longest period of dormancy in the mountain's recorded history. Previous inter-eruption intervals rarely exceeded 2 centuries. By historical standards, Fuji is overdue. But volcanoes do not operate on human schedules. Overdue is a statistical artifact, not a prophecy. Fuji will erupt again, of that scientists are certain. When, however, remains unknown. Today, Mount Fuji is one of the most monitored volcanoes on Earth. The Japan Meteorological Agency operates a dense network of seismometers around the mountain, detecting earthquakes too small for humans to feel. GPS stations measure ground deformation with millimeter precision, tracking any swelling that might indicate magma movement. Gas sensors analyze emissions from fumaroles, looking for changes in composition that could signal unrest. Satellite monitoring adds another layer. INS, or interferometric synthetic aperture radar, can detect ground movement over large areas with extraordinary precision. Any inflation of Fuji's edifice would be detected immediately. Early warning systems are in place. If Fuji shows signs of imminent eruption, authorities can issue alerts and implement evacuation plans. Ashfall models predict how ash would disperse based on wind patterns, allowing targeted warnings. But monitoring is not prevention. When Fuji awakens, we will watch and prepare, but we cannot stop it. If Fuji erupted today as it did in 1707, the consequences would be catastrophic. Tokyo's population has exploded from 1 million in 1707 to 37 million today. The metropolitan area is one of the world's largest urban agglomerations, with infrastructure, economy, and population density unimaginable to Ito's residents. A Hōei-scale eruption would paralyze the capital. Ashfall would close Narita and Haneda airports, stranding hundreds of thousands of travelers. Train service would halt ash, damages engines, and disrupts electrical systems. Roads would become impassable. The Tokyo Stock Exchange, one of the world's largest, would cease operations. The economic impact would be global. Tokyo is a crucial node in international finance, technology, and trade. Disruption lasting weeks or months would reverberate through supply chains worldwide. But the immediate human cost would be higher still. Ash would contaminate water supplies, requiring massive emergency distribution of bottled water. Respiratory illnesses would spike, overwhelming hospitals. Roof collapses would kill or injure thousands. Estimates suggest a modern eruption could cause direct economic losses exceeding $2 trillion, roughly 4% of Japan's GDP, and take years to recover from. The 2011 Tohoku earthquake provided a chilling reminder of what tectonic events can trigger. That magnitude 9.0 megaquake, like the 1707 Hōei earthquake, was a subduction zone megathrust. It occurred along the Japan Trench, where the Pacific Plate subducts beneath North America. The earthquake triggered a devastating tsunami, killed more than 15,000 people, and caused the Fukushima nuclear disaster. It also raised a troubling question. Could Tohoku trigger volcanic eruptions, as Hōei did with Fuji? In the months and years following 2011, seismic activity increased at several Japanese volcanoes. Mount Fuji erupted in 2014, killing 58 hikers. While scientists could not definitively link Fuji to Tohoku, the temporal proximity was suggestive. Fuji, for its part, showed minor signs of unrest. Seismicity increased slightly. Some researchers detected slight inflation, but no eruption occurred. The question remains open. The Tohoku earthquake may have brought Fuji closer to eruption by altering regional stress fields, even if it did not immediately trigger one. The clock is ticking. Japanese authorities have prepared extensively for Fuji's next eruption. Hazard maps identify areas at risk from various volcanic phenomena. Lava flows would primarily affect the mountain's immediate slopes. While dramatic and destructive, lava typically moves slowly enough that evacuation is possible. Communities near Fuji have evacuation routes and designated shelters. Pyroclastic density currents, superheated mixtures of gas and volcanic debris that flow down slopes at hurricane speeds, are more dangerous. These currents can travel tens of kilometers, incinerating everything in their path. Hazard maps identify valleys that could channel pyroclastic flows, designating them as high-risk zones. But the greatest threat is ash. Prevailing winds blow from west to east, meaning Tokyo lies directly downwind. Simulations suggest that an eruption comparable to Hōei could deposit 10 centimeters or more of ash across Tokyo within days. Public education campaigns have attempted to prepare residents. Pamphlets explain how to seal homes against ashfall, where to obtain protective masks, how to clear ash safely. But preparedness remains uneven. Many Tokyo residents, like Edo's citizens in 1707, find it difficult to imagine their familiar landscape transformed by volcanic catastrophe. Despite, or perhaps because of its volcanic nature, Mount Fuji remains sacred. Each summer, when snow melts from the summit trails, tens of thousands of pilgrims climb the mountain. They ascend through the night, hoping to reach the crater rim in time to watch sunrise from Japan's highest point. The pilgrimage tradition is ancient, but it has adapted to modernity. Climbers use headlamps instead of torches, synthetic fabrics instead of cotton. Mountain huts provide warm meals and places to rest. But the spiritual dimension persists. Many climbers pause at shrines along the route, offering prayers and coins. At the summit, they visit Kusushi Shrine, bowing before the deity of the mountain. The act of climbing remains, for many, an act of worship. This tension between Fuji as spiritual symbol and Fuji as geological threat defines Japan's relationship with the mountain. It is loved because it is beautiful, revered because it is powerful, feared because it is alive. Predicting volcanic eruptions remains imperfect science. Volcanologists can detect precursors, increased seismicity, ground deformation, changes in gas emissions, but translating these signs into precise eruption forecasts is difficult. Some volcanoes show dramatic precursors months before erupting. Others erupt with minimal warning. Fuji presents particular challenges. It is a complex system with multiple potential magma sources and pathways. Will the next eruption occur from the summit, as most historical eruptions have, or from a flank fissure, like the Hōei event? Will it be explosive or effusive? Large or small? Computer models attempt to simulate these scenarios, but models depend on data. And while we can measure the mountain's current state, we cannot observe its deep interior directly. We infer magma chamber depth, size, and composition from seismic tomography and geochemical analysis, but uncertainties remain. The best science can offer is probabilistic forecasting. If certain precursors appear, the probability of eruption within a given time frame is X%. But certainty is L continue 928 emelisive. And so we watch and wait and hope that when Fuji awakens, we will have enough warning. There is one more legacy of the Hōei eruption, subtle but profound. It changed how Japan thinks about disaster. Before 1707, volcanic eruptions were seen primarily through a spiritual lens. They were manifestations of divine anger or tests of faith. The response was prayer, ritual, appeasement. The Hōei eruption, coming during the rationalist currents of the mid-Edo period, prompted more analytical thinking. Scholars began documenting the event systematically, recording ashfall thicknesses, tracking economic impacts, analyzing recovery strategies. This empirical approach laid groundwork for modern disaster management. Japan's current preparedness culture, its earthquake drills, tsunami warning systems, comprehensive hazard mapping, evolved from lessons learned in events like Hōei. The eruption taught that prayer alone was insufficient. Preparation mattered, organization mattered, knowledge mattered. In this sense, the Hōei eruption's legacy extends far beyond volcanology. It shaped a national character that takes disaster seriously, that prepares meticulously, that learns from catastrophe. When will Fuji erupt again? Ask a volcanologist, and the answer is cautious. Probably within the next century, possibly sooner, but no one can say for certain. What we know is this: magma continues to accumulate beneath the mountain. Seismic studies reveal a magma chamber at depth, slowly refilling. The pressure increases, molecule by molecule, year by year. We know that the tectonic forces that triggered the 1707 eruption remain active. The Philippine sea plate continues to subduct beneath Honshu at 4 centimeters per year, building strain along the Nankai Trough. The next great earthquake there expected within decades could serve as trigger, just as the Hōei earthquake did. We know that Fuji's dormancy, while historically long, is not unprecedented in geological terms. Some volcanoes sleep for millennia before awakening. 3 centuries is, to the mountain, barely a moment. And we know that when Fuji erupts, it will erupt into a vastly more complex and vulnerable world than existed in 1707. The view from Tokyo on clear winter days. Fuji's snow-capped summit is visible from Tokyo's skyscrapers. Office workers pause at windows, tourists snap photographs, commuters glance up from train platforms. The mountain appears as it always has, serene, symmetrical, sublime. It seems impossible that something so beautiful could be dangerous. But beauty and danger are not opposites. They are, in Fuji's case, inseparable. The same forces that built that perfect cone, the rising magma, the explosive eruptions, the slow accumulation of layer upon layer, are the forces that will one day destroy it and build it anew. This is the nature of stratovolcanoes. They are not permanent. They are processes ongoing, dynamic, alive in the truest geological sense. Step back, consider what Mount Fuji represents. It is, at its core, a relief valve, a place where the planet's internal heat escapes to the surface. The Earth generates enormous heat through radioactive decay in its core and mantle. That heat must go somewhere. It drives the convection currents that move tectonic plates, that build mountains, that trigger earthquakes. Volcanoes are where that heat finds direct expression. Magma rises from depths of tens or hundreds of kilometers, carrying thermal energy from the planet's interior. When it erupts, that energy is released as lava, as explosively expanding gases, as the violent fragmentation that produces ash. Without this process, Earth would be geologically dead, a cold ball of rock like Mars, incapable of sustaining the dynamic conditions necessary for life. Volcanoes are not aberrations. They are essential to planetary function. They recycle materials, build new land, release volatiles that form atmospheres and oceans. Over geological time, volcanic activity has shaped every aspect of Earth's habitability. Mount Fuji, then, is not merely a mountain. It is a window into planetary processes, a reminder that we live on a world that is profoundly, endlessly, creatively violent. Humans have always lived in the shadow of volcanoes. From Vesuvius to Kilauea, from Krakatoa to Pinatubo, we build cities at the feet of fire mountains, cultivate their fertile soils, drink from their springs. Why? Partly it is necessity. Volcanic regions are often agriculturally rich. Ash weathers into fertile soil. Geothermal energy provides heat and power. The land is productive, and productivity draws people. But there is something else, a fascination, perhaps even a spiritual pull. Volcanoes are awesome in the original sense of the word, inspiring awe that mixes fear and wonder. They remind us of our smallness, our vulnerability, our place in a universe of forces beyond our control. Mount Fuji embodies this paradox perfectly. It is revered as sacred, depicted in countless artworks, climbed by millions. Yet it has killed thousands, destroyed cities, altered history. We love it because it is dangerous. We fear it because it is beautiful, and we cannot look away. The snow falls softly on the summit. Another winter, another year, another layer of white covering the scars of the Hōei crater. From a distance, the mountain appears unchanged, eternal, immune to time. But beneath the snow, beneath the ice, beneath the thousands of meters of layered rock, heat persists. Magma rises, pressure builds, the Earth's restless heart continues its slow, patient work. Mount Fuji will erupt again. Not if when. And when it does, the world will remember what those who lived through 1707 knew. That nature's power dwarfs human ambition. That beauty and danger are inseparable. That the ground beneath our feet is never as solid as it seems. The sleeping god will wake. The ash will fall. The earth will tremble. And in the aftermath, as in every aftermath, humans will rebuild, adapt, endure. We will tell stories about the eruption, paint it, photograph it, study it. Because this is what we do. This is who we are, a species that lives on the edge of volcanoes and calls them sacred. Mount Fuji stands, silent, white, perfect. For now,